Saxon Math Course 3, we're going to be talking about Lesson 12 and decimal numbers. So this first part is asking us to actually write out what the words are and how we would say this number. And so, we're used to saying stuff like 12.05, right? And that is the simpler way, but that's not what we want to do. Here, we want to talk about what's going on in each of these places. So we know that this is just a quick reminder, the tenths place, this is the hundredths place. So when you answer this question, you want to include the number that we have here. So after the decimal, this is called 5. This is just all 5, right? 5 hundredths. You don't have to say 12 and 0 tenths and 5 hundredths. So we're just going to write 12 and 5 hundredths. So here's what we have, 12 and 5 hundredths. Let's look at 12 and 5 hundredths. By the way, the word and in math is really reserved for that decimal point. So, when people look at this number and they say 125, though, if you ever talk to somebody like old people, they say, don't say and, it's 125, but this is 12 and. So the decimal point is the and when we talk about that in math. Just a little side tidbit. Okay, let's look at this next one. So we have 0.125, which is not what we're going to say. We're going to look at this whole number and think about the place of this last digit. This whole number is 125, but this last digit is going to be, so you know that this is tenths, hundredths, thousandths. So 125 thousandths is the answer there. 125 thousandths. In this example 2, we're going to be organizing these numbers from least to greatest. And honestly, the best way to do it is just to first look at the numbers, kind of compare their place, and honestly, writing it like this is quite helpful because it gives you a better understanding of how they all play out. I would even go as far as to fill out the number a little bit. So we see we've got 3 digits after the decimal. So let's make everything have 3 digits after the decimal. Now it's really clear to see that this is the largest and this guy over here is the smallest, and these guys come one after another, this one first and this one second. So I don't know if that's helpful to you, but I like to think about it like that. And then so I'm going to write my answers from least to greatest. So the smallest one is going to be the 0.05, which we know to be 5 hundredths. Then we're going to come over here and recognize the next one is 405 thousandths, then 400 or 41, this would be 410 thousandths, but if I honor it the way it's written, it's really 41 hundredths, still larger, 41 hundredths. And then this last one is going to be 5 tenths or 500 thousandths. Okay, but 5 tenths. So 0.5. There, good. So in example 3, we're going to be writing these decimals as a reduced fraction. A couple ways to do this. I don't know. I'm not even sure which one is your preferred way. But when I see 2.8, you literally can put it over 1, and then you can make both of these whole numbers. So, you're going to make the numerator a whole number, and that means your denominator has to have its decimal place move over. So 2.8 over 1 is the same as 28 over 10. Does that make sense? Do you see that movement of the decimal place kind of over? So now you can take this and make the fraction that you want. So it says write each decimal as a reduced fraction. So I got to reduce this bad boy, and I'm going to get divide top and bottom by 2. I'll get 14 over 5. So we could leave it at 14/5. They did say leave it as a fraction. So this is a fraction in the most reduced term. If you're feeling itchy and you just really have to make it a mixed number, 5 goes into 14 2 times with the remainder of 4. So we get 2 and 4/5, which we can see 2.8 is 2 and 4/5. So it makes sense. Okay, so if we're going to be changing 0.75 or 75 hundredths into a fraction, I'm going to just put that 0.75 over 1, and then I'm going to do what I did before. I'm going to move the decimal place over enough so I have a whole number in the numerator, and however many times I move that decimal place in the numerator, I got to do the same thing in the denominator to maintain equality. So now 0.75 is 75 over 100, and I think you already know the deal. We're going to divide the top and bottom by 25 because we're going to reduce this fraction, and when we do that, we get exactly what you thought, 3 over 4, because 75 divided by 25 is 3, and 100 divided by 25 is 4. So here in this one, we're going to be taking this fraction and we're going to make it a decimal number. So this is going to be some division that we're going to experience here. So let's check out 4a. You take 3/8, and basically, let's remember, this is an important fact. The fraction bar is like a division bar. 8 is being divided into 3. No, let me try it again. 3 is being divided by 8. I said it wrong, but you know what I'm saying. So if we think about dividing, we are going to take our divisor, which is the denominator, and divide it into the numerator. Now, you should be saying 8 doesn't go into 3. That's right, because it's not a whole number. We already know we're dealing with a fraction, so our expectation is that we're going to get a decimal. So since this is 3.00 whatever, right, we could write as many zeros as we want. It's still 3. Since this is 3 decimal point, we're going to put a decimal point up here, and then I'm going to just start adding zeros. Now I know that 8 can't go into 3. I'm going to put X there. 8 does go into 30, so now I'm starting my number after this decimal point. 8 goes into 30 3 times. 3 times 8 is 24. When I subtract that, I get 6. I can add as many zeros as I want, and I'm going to do just that. 8 will go into 60, goes in there 7 times. 7 times 8 is 54. I feel like we did this recently. That's all right. And then we're going to get 6 down here. Now I'm going to drop another 0. 8 goes into 60 7 times. Oh no, my math is wrong. Schnappables. Okay, so for here in this example for A, what we're going to be doing is taking this fraction or mixed number, as you see we have one here, and we're going to change it to a decimal number. So basically we're going to be dividing 8 into 3, all right? That's exactly what's going on here. When you see a fraction bar, I do want you to think division. Since 8 can't go into 3, we're going to add a little bit of decimal points and see what happens. A little bit of zeros after a decimal point, and we'll see what happens. Look at how I lined this up. I put my decimal point down here and my decimal point up here. 8 can't go into 3, but 8 can go into 30. It goes into 30 3 times. 3 times 8 is 24. When I subtract, I get 6. Drop this 0, I get 8 going into 60. 8 can go into 60, and it goes in there 7 times. The product of 7 and 8, 7 times 8, is going to be 56. When I do that, I get 4. I'm going to drop this 0. 8 goes into 40 5 times. 5 times 8 is 40, and so I'm done. So what we have is that 3/8, let me write it over here, 3/8 is equal to 375 thousandths. Let's go on and do this next one. So B is a little bit more involved because we have 2 1/2, which is, well, it's not really that much more involved, to be honest. We have 2 1/2. The fact is, this is already a whole number. We really need to focus our attention on the fraction, and we're going to change that fraction. We're going to change that fraction to a decimal number. So we get 2 point, and whatever this fraction is, when we change it to a decimal, we're just going to stick it right there at the end. And I'll put the highlighter here just so we can see that. All right, so it's pretty straightforward. We're going to be dividing 2 into 1. I know you already know the answer to this, but let's just have fun. Let's do it anyway. So 2 cannot go into 1, but 2 can go into 10. Goes 5 times. 5 times 2 is 10. And honestly, we're done. If I drop the 0, I'm just going to be adding more zeros here. So we get 0.5 or 0.5, which is going to be 0.5 when I add it here. You probably didn't need to do this division for that, but it's nice to see that it all works. So this is pretty cool. Example 5 is probably one of the most fun, exciting things you'll do. When I say that, I really just mean easy. 5a, if we look at it, we're going to take this decimal and we're going to convert it to a percent. And so to convert it to a percent, you're really just going to multiply it by 100. And the cool thing is multiplying by 100 is so fun and easy because you're really just moving the decimal place twice over. So zero point 0.2 as a decimal is really going to be, multiply that zero point 0.2 by 100, it's really just going to be 20. You see that? So we've multiplied this by 100, move the decimal place over, and you've got 20. Let's try 5b. So 5b, we start off with 0.125. And again, we're multiplying by 100, which really means we are moving that decimal place over 2 spaces to the right. 1, 2, and you can see by multiplying by that 100, we end up with 12.5. And I'm looking for my black pen here to write it like that, 12.5. Let's do it one last time. In C, we have 1.5, multiplying by 100 again to change it to percentage. So each of these, by the way, I should write it like this. These are percentages, all right? So 0.2 decimal is equal to 20%. 0.125 decimal is equal to 12.5%. 1.5 decimal, again, we're going to go back in there and we're going to move that decimal place over 2 spaces to symbolize multiplying by 100. When we do that, we're going to see that our answer is going to be 150%. So it's one whole and then 50. 1.5, one whole, then 50 gives us 150%. I hope that's making sense. I hope that's making sense. All right, let's see what else we got. So the process of going from percent to percent to decimal is just as easy as the process of going from decimal to percent. So you remember, basically 5% is out of 100, right? That's what it is if we're doing the fraction part. So basically we're dividing this by 100. Division by 100 is really straightforward as well. You're going to take that percentage, in this case it's 5%. You're going to take that percentage, that 5, and you are going to move the decimal place 2 spaces to the left. Boom, boom. That's now the decimal version of 5%. Let's think about what we would call this number. If I were to write this number out, I would say it's 0.05. You see that? Boom, boom, the decimal point's here, so I got 0.05. 0.05%. But how do we say this number? This is 5 hundredths, which makes sense. 5% is 5 hundredths. So we're just going to do that for this next one as well. So we take that 225 that we have here. We are going to move the decimal point back 2 spaces, 1, 2, and then so we end up with 2 and 55 hundredths. That's what we have. This is the decimal version of this percentage, and this is the decimal version of this percentage. So we got one of our favorite problems, which is to arrange things from least to greatest, but sometimes it gets kind of crazy because we've got all this stuff going on. We've got fractions, we've got percentages, we have regular numbers or decimal numbers. So one thing we might want to do is convert everything to one type of number, which is fine because we know how to make everything a decimal pretty easily. 1/2, let me go ahead and write that down. So here's example 7. We've got 1/2. We have 12%, we have 1.2, and negative 1.2. Well, I know this negative 1.2 is the smallest, so I'm feeling good about that. And it's these other ones that are kind of confusing to me. So I'm going to go decimal route with all of this. 1/2 as a decimal, we've done this enough to know that that's 0.5. If I divide 2 into 1, that's what I'm going to get. 12% as a decimal is just moving the decimal place back 2 spaces, so that's going to be 0.12 or 12 hundredths. This is already in its decimal form, as is this. So now I'm ready to go. I realize that the smallest number is this negative 1.2, as I expected. And then the next number that is the smallest is going to be 0.12. The next number is going to be 0.5. And the largest number is 1.2. If you want to write it in its original form, you can do that. So the 0.12 was 12%, and the 0.5 was 1/2. And then the 1.2 is as it was. So here we are in example 4. We're talking about how much money is 80% of 40, how much money is 75% of 40, and estimate $8.25 sales tax on this $19.95 purchase. Okay, so we got a lot to unpack here, but what you're going to find is that it's not too difficult to find 80%. One of the best things to do to find 80% of a number of still has that desire for you to multiply. Let me get my notes up one more time. Hold on. All right, to find 80% of still means to multiply. And so what I'm going to ask you to do is to take your 80%, change it to a decimal. So you remember we're just dividing by 8. Dividing by 100. We're going to get 0.8 and we're going to multiply by 40. That is it. That is going to give me what 80% of 40 is. So I want you to think about 80%. 80% is more than 50. So I do expect this number to be bigger than 20. I like to think about stuff like that just to make sure I'm on the right path. So when I multiply 40 times 0.8, really is like multiplying 40 times 8 and I get 320. But what I do is I have to count the decimal points. So I've got one decimal point here, so I'm going to move this over here. So my answer is 32, which makes sense to me, right? That is a lot of 40. That's 80% of 40, which is more than 50%. All right. All right, let's think about this next one. B. B is asking 75% of 40. So instead of doing 0.8, I'm going to change that 75% into the decimal 0.75. Remember, we're just moving the decimal place 2 spaces to the left, and I'm going to multiply that by 40. When I do that, 40 times 75.75, I'm going to act like I'm just multiplying regularly. So I get that there, I get this here, put my 0 here, shift it over. 7 times 0 is 0, 7 times 4 is 28. When I add all of this together, I end up with 30. You probably could have calculated that yourself, but I'll show you how I get 30. My bad. I end up with 3,000, but I've got to count my decimal places. 1, 2, and then I see that that's 30. And if you think about 40 split up into 4 equal places, and I get 75% of it, or 3/4, you can see that that's 30 also. So you might have thought about that as well. All right, so that's how we can do that. Let's go ahead and try this next one. Estimating sales tax on this purchase. Since they said estimate, that feels like, for me, I'm going to try to use convenient numbers. So 1995 is not super convenient for me. So what I want to do with this 1995 is I'm going to calculate 8.25%, or 8.25%. I wrote it as a decimal, so I don't need the percentage there. Times, I'm not going to do the 1995. I'm going to do 20. Right? So if I multiply these two, again, I'm multiplying 20 times this number. I'm going to write this number at the top, 825, and have my little decimal over here. So I'm going to multiply this. 0 times all of that is just a bunch of zeros. Then multiply 2 times all of that. Got to move it over because of the fact that 2 is in the tens place. So I put a 0 here. 2 times 5 is 10, carrier 1. 2 times 2 is 4, plus 1 is 5. 2 times 8 is 16, carrier 1. 2 times 0 is 0, and I put the 1 here, and I'm done. So now I'm going to add all of this together, and I get 16,500. But remember, we're counting decimal points. 1, 2, I'm sorry, bad counting. 1, 2, 3, 4. So I am going to move this over 1, 2, 3, and 4. So what I see here is the sales tax. $1.65 is the approximate. I'm going to use these wavy lines. Is approximate sales tax for a purchase that is $19.95. Let's go ahead and see what our text had. I think everything we have is pretty good. They did the same thing. Actually, they rounded the 8.25 to 8, which is nice. And when they did that, they got $1.60, which is pretty good. I think I got $1.65 or whatever. So nice. And now we're up to the practice set. And now you are prepared to go on and do the odd problems of the written practice. Listen, I look forward to talking to you soon. Take your work seriously. Do the best you can. And I can't wait to see you on Tuesday. Take care. Bye-bye.